Hello my dear students, how are you? I hope all of you are doing very well and safe. Today in this video we will be learning about product of vectors. Last few videos we have seen what are vectors, their basic concepts, and then of course addition and subtraction of vectors, triangle law of vector addition, parallelogram law of vector addition. In this video what we are going to do is we are going to learn how do we multiply vectors also. There are basically three types of multiplication of vectors. We are going to be learning all the three slowly. In this video, we will be learning about the first two ways of multiplying vectors. And in the next video, we will discuss about the third one. Of course, the first one is very simple. Then we'll be basically focusing only on the second and the third multiplication of vectors. Of course, the first one is very simple, multiplication of a vector by a scalar. So that concept will not waste much time. Now, first one is like multiplication. I'll just write it in short. Multiplication of a vector by a scalar. Then the second one is called scalar product of two vectors, and the third one is known as the vector product of two vectors. So these are the three ways of multiplying vectors. The first one, as I said, it's a very simple topic. We will discuss that in just maybe less than a minute. Then we have the scalar product of two vectors and also the vector product of two vectors. These two are going to be very important. Scalar product of two vectors is also known as dot product of two vectors, and vector product of two vectors is also known as cross product. Cross product of two vectors. Okay, now what happens, I'll just explain it to you in brief, and then of course one by one we'll be studying them in detail, but very briefly of course. So get your notes, paper, pen, everything ready, start writing down the notes which I will be giving you, and yes, do watch the full length. Scalar product of two vectors. Now what happens is the second, I'm not going to be discussing about the first one as I said, okay, it's a very simple topic, but briefly let me tell you what are these two. Scalar product of two vectors. So what are we going to do here is we are going to be learning about how to multiply two vectors, isn't it? That is vectors into vectors. Now in this second one, what happens is when we multiply two vectors, we will be getting a scalar quantity. Now by now of course already I believe all of you are very familiar with what are vectors, what are scalars. If not, then please go through the previous three videos. You go through that, then definitely the concept of vectors and scalars will be, I believe, clear up to some extent. So in scalar product of two vectors, what happens is you go for the multiplication of two vectors, we will get a scalar. Then in the third one, when we go for the multiplication of two vectors, we will be getting a vector quantity. Okay? So let's discuss them, discuss these three topics one after the other. As I said, in this video I will discuss only the first two methods. First one, very simple, multiplication of a vector by a scalar. So I'm going to keep it very simple. That is like, for example, if you have a vector quantity, with example only I'll explain. So let's say like 3i plus 4j plus 5k. Let us assume that we have a vector quantity, that is vector a equal to this. Now what I'll do is I'll see multiplication of a vector by a scalar. A scalar can be any quantity, any constant quantity. So if I multiply this by 5a, where 5 is the scalar. In general, of course, we write lambda a vector, where lambda is that constant quantity. So here I have assumed lambda to be 5. So in that case, what happens is simply 5 into this vector quantity for j plus 5k, so that result will be 5 to the 15i 20j plus 25k unit vector of the z-axis. Alright, so that's why I was telling you the first point, we will not be wasting much time. It's a very simple topic, so that's it. Nothing more here, but that's the end. That's the end of the story here. Second topic. Now let's study the second topic in detailed manner. Scalar, or we also call it as dot product of two vectors. So now, henceforth, especially when you do the topic vectors and scalars, vector algebra, you need to be very careful in the way you write the dot and the cross also, because that will mean either you are doing dot product or you are doing cross product. So you have to be careful, especially when you are doing vectors. Okay. Scalar dot product of two vectors. Now let us assume two vectors. Let's say vector A and let's say vector B. Okay, let us assume two vectors. Let's vector A and vector B, and that they are making an angle theta. They are making an angle theta between them. Of course, we have the special cases when they are parallel in the same direction, when they are perpendicular. Don't worry, have patience. We're going to study one after the other. Now, in general, if they are making any angle theta, 10, 20, 30 degree, something like that, for something like this, vector A might be here, vector B might be here. So how do we multiply these two vectors? How do we add? We already studied in triangle law, parallelogram law, and so on. How do we multiply? That's what we're going to study here. So if you have two vectors making an angle theta between them, then what happens is the dot product of these two vectors is given by magnitude of A into magnitude of B into cosine of the angle which the two vectors are making with each other, which vector A is making with vector B. Dot product of two vectors is equal to what? Magnitude. We already know how to find out all this. Magnitude of vector A into magnitude of vector B into cosine of the angle which the two vectors are making between them. Alright, or in other words, we know that vector A, magnitude of vector A also can be simply written as A, magnitude of vector B also can be written as simply B, and cos theta, because a vector without a direction is having only magnitude, which is also just a scalar quantity. Now that's all this we already studied. Alright, so yeah, this is it. This is how we are going to be going for the dot product of two vectors. Now let's see some special cases. Okay, let's see some special cases. First one, the first special case, that is, yeah, of course you might be wondering about the parallel perpendicular. Okay, see, before we go for that, if theta equal to 0 degree, then what will happen? Just imagine, if theta equal to 0 degree, it means vector A is parallel to vector B. If theta equal to 0 degree or pi, right? 0 degree, if the angle between vector A and vector B is 0 degree or 180 degree, it's all the same, like and unlike vectors, then in both of the cases it means that vector A is parallel to vector B. And if theta is equal to 90 degree, then it means that vector A is perpendicular to vector B. This perpendicular word, sometimes we also call it as orthogonal, orthonormal. They are also known as orthogonal, orthogonal vectors. So sometimes don't be confused if the question states prove that the two vectors are, or check whether the two vectors are orthogonal vectors or not. So orthogonal simply means whether they are perpendicular or not. Okay, not be very confused with that. Now, let's study the special cases one after the other. Okay? Let me write down the formula once again. That is magnitude of dot product of two vectors is magnitude of A into magnitude of B into cos theta. Now, the first special case, that is if vector A is a zero vector, or if vector B is a zero vector. If any one of the two vectors is a zero vector, then that's very simple. then what will happen to the dot product? Then the dot product of the two vectors will be if either A or B. If anyone is 0, see 0 vector, magnitude of 0 vector will be 0 only. So then the dot product of the two vectors will be 0. Alright. Number 2. Yes, now I just overlapped, I just stepped upon one point, that is like scalar dot, the name itself justifies, no? The name itself justifies, S-C-A-L-A-R, scalar or dot product. Scalar or dot product itself justifies the second one, which I already mentioned, that is when you go for the dot product of two vectors, you will end up getting a scalar quantity. You will not be getting a vector quantity anymore. Got that point, no? When you go for the dot product of two vectors, the result is not a vector anymore. The result is a scalar quantity, which is very clear in one of these examples also. That is, if any one of the two vectors are 0 vectors, then the dot product will be 0. Now 0 is a scalar quantity, isn't it? 0 is just magnitude. It doesn't have a direction. Second condition, that is, if I hope you're writing down the notes, if A and vector B are, let's say, like vectors, if vector A and vector B are like vectors, if you remember what, theta is equal to 0 degree, parallel in the same direction. So if vector A and vector B are like vectors, that is if theta is equal to 0 degree, then what will happen to the dot product? A dot B will be magnitude of A into magnitude of B cos of 0 degree. So magnitude of A, we just write A, magnitude of B, cos 0 degree is 1. So that means it is simply going to be A into B. That is magnitude of vector A into magnitude of vector B. Alright? Okay. Third condition, I'll just overwrite here. I hope these things are done. The third case, that is if vector A and vector B are unlike vectors. If vector A and vector B are unlike vectors. Unlike vectors means parallel vectors but in the opposite directions. That means that angle is going to be how much? 180 degrees. So in that case, the dot product of two vectors will be magnitude of vector A, magnitude of vector B in the cos of 180 degree. Now cos of 180 degrees is minus 1. So the result will be minus of magnitude of vector A into magnitude of vector B. Alright. Of course, you can also write, you can keep it like this also, not a big problem. Okay, minus of magnitude of A into magnitude of B. It's just that in simple, we just write minus AB, just the magnitudes. Okay, alright. The fourth condition, number 4, the fourth special case. The fourth special case is if vector A and vector B, if vector A and vector B are orthogonal vectors, orthogonal vectors or perpendicular vectors, that is theta is equal to 90 degrees. This is a special case, okay, special case for dot product. All are special cases but more commonly used this one. Then in that case, what will happen is dot product of two vectors will be magnitude of A, magnitude of B, cos of 90 degree. Now what is cos 90 degree? 0. That means the whole value is 0. So sometimes, we have a lot of questions based on this. That is, prove that the two vectors are orthogonal. Check whether the two vectors are perpendicular or not. So in that case, what we can do, one of the tools that we can use is we can go for the dot product of two vectors. And if we find the dot product of the two vectors to be 0, then we can go on to state that since the dot product of the two vectors is 0, the two vectors are perpendicular to each other. Okay? Alright. Now, another important, very, very important for vector, scalar dot product, the name itself justifies scalar dot product, is this orthonormal, orthonormal triad of vectors, normal vectors Orthonormal triad of vectors. Now we know that, see, I cap, j cap, k cap. These are actually what? No matter in what direction that you use, x, y, z, whatever direction you use, I cap actually represents the unit vector of x-axis, j cap represents the unit vector of y, and k cap represents the unit vector of z-axis, and they are perpendicular to each other, isn't it? Perpendicular to each other, just like Fleming's left hand rule, they are always perpendicular to each other, no matter the direction that you take. All right. Now, if I, j, k represents this unit vectors of the x-axis, y-axis, and z-axis respectively, then let's see some special conditions which are going to be very, very important for our dot product, algebraic product of two vectors. What will be the first case? What will be the value of I dot I? Now, I already mentioned about this case before. I dot I, these are what? Like vectors, because I dot I, both are like vectors in the same direction, if you remember. So that's going to be magnitude of I into magnitude of I cos 0 degree. Now what is I? I cap. I cap represents a unit vector in the direction of the x-axis. Unit vector, that means its magnitude will be 1 into, this also will be magnitude of 1. Scalar quantity. So when you're doing scalar quantities, no problem, you can write cross or dot, okay, that's fine, because you have to be just careful when you're dealing with vector quantities. And cos of 0 degree is how much? Cos of 0 degree is 1. So that means I dot I will be 1. Alright, going to be very useful. Okay, similarly, j dot j, k dot k will be 1. Alright, some of you might argue that previously in a special case, for like vectors we get my dot product of two vectors is a dot vector a dot vector b is equal to ab. We don't get 1. Yes, we will not get 1 because there we were not dealing with unit vectors. A and b were not unit vectors. A and b were just some other vectors, right? Here, of course, we're dealing with unit vectors, and that's why this magnitude turns out to be 1. That's the only reason. Okay? So I dot I, j dot j, k dot k will be 1. What about orthogonal vectors? Orthogonal vectors like subcondition B. Let's say this is A. What about I dot j? If you go for this product, like, so we know that I and j are there mutually, because something like this y-axis is pointing outwards. Okay, y-axis is something like this. All right. So they are perpendicular vectors. So I, j, perpendicular means 90 degree. Just now we studied that. So it is going to be how much? 0, 0, 0. All right. Similarly, I dot j, j dot k, k dot I. This will all be 0 vectors, or j dot I will be 0, k dot j will be 0, I dot k also will be 0. So here generally the direction doesn't matter that much with the product. It's not, it will matter in cross product. Okay, but dot product, since outcome will be a scalar quantity, then okay, that's fine, we can live with that, not a big issue with that. Okay, so this is something which is going to be very, very, very important. Alright, we will do some examples on that also very soon. At the end of this video, I will be doing one example on how to really multiply two vectors. Now another topic which is also quite important, that is projection. Projection of a vector. Projection of a vector on a line. So all of you will be having your textbook, so you can just read through that. I will just briefly tell you exactly, like in brief, what is projection of a vector. What do we mean by projection of a vector? For example, we have a directed line, let's say L. Okay, for example, we have a directed line L. And then there is a vector which is making an angle of theta. Okay, let's say B. Okay, let's just say, alright, let's say OB. Alright, we have this vector OB represented by phi vector B, making an angle theta. Correct? We have a directed line and then we have another vector b vector or OB vector, which is making an angle of theta in the anticlockwise direction. Then if we drop a perpendicular from the point B to the line, let's say M, okay, then this OM is called OM. Of course, OM vector, this OM vector, let us assume that it is A. OM vector will be called as the projection. OM vector will be called as the projection vector, and OM, the magnitude, its magnitude is called the projection of this vector, projection of OB vector on the directed line. Alright, so it's something like its shadow, something like that, not mathematically or technically, but projection simply means the length of the length of the shadow, something like this. So if this is a directed line and then we have a vector, so what is the projection of this vector on this line? So what we do is we drop a perpendicular and then just see. So it's something like, what is the shadow that is being cast by this particular vector on this line? Something similar to that, sort of that concept. So the projection of this vector on this line is this one, after we drop a perpendicular, of course, OM. So OM is called the projection of, don't confuse, projection, OM is the projection of this vector on the directed line. Okay, got that? Simple as that. Now the formula, how do we really calculate? So OM, what is it? OM is the projection of vector on a particular line, that is projection. OM now is a projection of which vector? Of vector B, isn't it? OM is the projection of vector B on the which directed line? On vector A. We have named the directed line as, let's say, vector A, isn't it? So this OM is the projection of B vector on the directed line vector A, and that will be given by the dot product of vector A into vector B upon its magnitude, or in other words, vector B multiplied dot product of vector B and the unit vector of the directed line, because see, this is the unit vector of the directed line. Alright, or otherwise it's simply dot product A dot B into divided by its magnitude, or in other words, the vector dot product of the vector and the unit vector of the directed line. So this will be the projection. This is called the projection of a vector on a line. Alright, just in case, like we may have sometimes like this is the vector B, this is the vector A. So in that case, what projection will be of vector A on vector B? So that will be projection, I'll just write in short, projection of vector A on vector B. That will be what? Vector A into the unit vector of the directed line. So B upon magnitude of B, or in other words, A dot B upon magnitude of vector B, something like that. Okay, so it's not a very difficult topic, it's a very simple topic. Okay, just a small topic left there. We may have one or two problems to solve in the exercise, don't worry, which we will solve very soon in the coming videos. So that's what we have. Of course, yes, properties of scalar product. I will not be discussing in detail. Properties. Properties of scalar product. So in short, only we will discuss properties of scalar product. First is that it is commutative. That is, A dot B is going to be equal to B dot A. It's not going to happen in cross product, okay? We will discuss why. But that happens, not a big problem with that. So it is commutative, alright? And then of course we have some other properties also, but I don't think we will need that as of now. So we have this Cauchy-Schwarz inequality, we have the triangle inequality also. So all those maybe we will discuss in the other videos, in the next videos, along with the exercise, okay? Alright, so, but this is going to be an important property for us, okay? That's why I have just mentioned that that is scalar product obeys or follows commutative property, that is A dot B will be equal to what? B dot A. Because scalar quantities will not have direction, so that's not going to be an issue with us. Then of course, yes, angle between two vectors. Angle between two vectors. How do we find out the angle between two vectors? So if we have two vectors, vector A and vector B, and this is the angle that is being made between the two vectors, then how do we find out the angle that is being made between the two vectors? Simply by using the formula, that is A dot B is equal to what? Magnitude of A, magnitude of B, cosine of the angle. So in that case, if we just cross multiply, that's going to be A dot B upon magnitude of A into magnitude of B equal to cosine of the angle theta. So that means theta will be equal to cos inverse of A dot B upon magnitude of A into magnitude of B, and that's how we will be finding out the angle between the two vectors. Okay, I hope that is done. Anyway, since I already mentioned about the property, proof we will not do, but let me just give you the properties. Okay, first one, since I already mentioned, so properties of scalar product of two vectors. Maybe important for multiple choice questions also. Number one, A dot B is equal to B dot A. It obeys the commutative property. Another property is if A dot, which we have already studied, if A dot B is equal to 0, then what can we conclude? If A dot B is equal to 0, then we can conclude that either vector A equal to 0 or vector B equal to 0, or vector A is perpendicular to vector B. The first special case and the fourth special case, I guess. Alright, you can check your notes there. So if we get the dot product of two vectors to be 0, then either vector A is 0 or vector B is 0, or they are perpendicular to each other. Alright. Okay, then of course the third one that we have is the magnitude of the product, dot product of two vectors. The magnitude of the dot product of the two vectors is always less than or equal to the product, independent product of the magnitude of the two vectors. That is, magnitude of A dot B will be always less than or equal to their independent products of magnitude of the independent products of the vectors. This is also known as Cauchy-Schwarz. I forgot the spelling. Schwarz, Cauchy-Schwarz. Yeah, Cauchy-Schwarz inequality. Inequality. Cauchy-Schwarz inequality. Alright, this is also known as Cauchy-Schwarz inequality. Okay, alright. Then another property that we have is the triangle inequality. Triangle inequality. That is number 4, that is the magnitude of the addition of two vectors. The magnitude of the addition of two vectors is also less than or equal to the independent addition of the magnitude of the two vectors, and this is called the triangle inequality. Okay, this is also known as the triangle inequality. Alright, and then finally there is one more property, that is the distributive property. Distributive property, if you wish you can note down distributive property, that is A dot B plus C is equal to A dot B plus A dot C. That means dot product also follows the distributive property of addition. Distributive property of addition or subtraction also. Alright. Okay, so these are some of the properties. Proof, as I said, we will not be doing as of now. Maybe in the exercises. Then, all right, then as I said, let's try to solve, let's try to get one, let's try to learn one, how do we multiply dot products. Let's say one example, that is if we have two vectors, let's say vector A, 3i minus 2j plus k, and vector B. How do we just multiply? How do we just go for the dot product of two vectors? Algebraic, just product. Okay, how do we product? 3k. Then how do we go for the product of two vectors? Now here we will not go for cos theta, that formula and all, because we don't have the angle between the two vectors. So simply direct multiplication, that is plus k into I minus 2j minus 3k. Now listen carefully. You see, we will go for the normal multiplication, that is 3i into I. I'll just write 3i into 1i. 3i into 1i minus, okay, we'll just do it in detail. Okay, alright, minus 3i dot 2j minus 3i dot 3k. I'm just going for the plus minus directly. Similarly, minus 2j dot I minus minus plus 2j dot 2j minus minus again, that's going to be plus 2j 3k. Don't worry, we are not going to be doing such a long multiplication. This is just the first solution, that's why I'm just showing you what is going to happen. After that, I'll tell you exactly what to do, shortcut directly, don't worry. This one, plus dot product of k, I, plus minus minus, dot product of k, 2j, plus minus minus, dot product of k, 3k. Actually, this is what we are going to be doing with multiplication, isn't it? I am going to rub this off. Now we have already, you remember I gave you orthonormal triad of vectors, that is going to come in handy now. So now 3 into 1, that is 3. Now we have already studied I into I, how much? Well, I'm not going to do that again. You must have already written I dot I will be what? 1. Problem solved. Minus 3 2's are 6 into I dot j. What is dot product of I and j? Constant numbers, so it will be 6, isn't it? Now go for the dot product, that is I dot j. What is the dot product? Angle we are getting already here itself. Now I dot j, 90 degree, cos 90 degree, we already have studied. 0. Minus, this is also how much? 3 3's are 9, okay. I dot k is again what? 0. This one also, 2 into 1, okay, but j dot I, perpendicular vector, so theta is 0 degree, so that's how much? 90 degrees, so this is also 0. Here, plus 2 2's are 4, j into j dot j, that is 1, isn't it? I'm going to rub this off, j dot j, so this is done, right? This is also done. Next, plus, this is j dot k, that is also 0, k dot I, this is also 0, k dot j, this is also 0, plus, minus 1, 3 1's are, this is 1, so 3 1's are 3 into k dot k, that is 1. So that's what I say. Now it's very simple, but you need to know how it happens, right? So that means ultimately we have 3 plus 4. Is it minus, by the way? 3 1's are 3, minus minus 4, plus minus minus. Okay, that's fine. Plus minus, that's going to be fine, no problem with that. So that's going to be minus 3. So minus, so what is its value? 4. So you can see that when you go for the scalar product of two vectors, what do we get? 4. 4 is a scalar quantity, isn't it? 4 is a scalar quantity, that is exactly what I was telling you. That's why we even name it also scalar product of two vectors, or in other words, dot product of two vectors. Alright? So that's how we calculate. But the same question, I'll tell you now exactly what to do. Alright, remember, answer is 4. Now, when you go for the dot product of two vectors, once again I'm going to write 2j plus k. What you need to do, I'll tell you. No need to write all those steps which we did. Okay, that was just showing you what is exactly happened. All you need to do is, this is my way of doing it so that I can reduce my mistakes, limit my mistakes. I dot I, so 3 into 1, because I dot I know it's going to be 1. So after that, I will be just ignoring all the other values because I know that it is 0. So I'll go for I into I, j into j, k into k. The other values which we have already seen are 0, so we will not consider them. Alright? Plus, I prefer to write plus, bracket 2 into 2, minus 2 into minus 2. As I said, I'm trying to reduce my mistakes. Alright? Plus, again, whatever plus or minus, whatever values, you just go for plus, writing plus 1 into minus 3. So if you're careful with the brackets and then you just write on the specific values with plus, then what happens is this addition, subtraction, careless mistakes which generally students do, and that is avoided. Okay, it is avoided up to a lot of even I make a lot of mistakes, so careless mistakes. So in order to avoid that, so that's 3 minus minus plus 4 plus minus minus 3, so the value is 4 itself again. Alright, got it? Once again, when you go for the dot product of two vectors, ignore other values, just go for I into I, j into j, k into k. First thing. Second thing is, just write on the numerical coefficients, product of the numerical coefficients, 3 into 1, whatever, plus, minus, enter both. After that, you just write plus, 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 plus. Its numerical coefficient, you write it in brackets, so you can avoid some mistakes. That is minus 2 into minus 2, right? Then that product of the signs and all will come out automatically. Then plus 1 into minus 3, so plus into minus, minus. So that way, I'm very sure that your mistakes will be avoided 100%. Alright, so that's how we will be going for the dot product of two vectors, and definitely in the next video we will be trying to solve the exercises, and after that definitely go for the vector cross product, which is also a very interesting topic. Alright then, thank you for watching. I hope you have loved this video. Please do like if you have liked this video. Alright then, see you next time with the vector cross product and the exercise of this dot product.